Once again, thank you everybody for being here today. Javier, thank you for that wonderful presentation. That was fantastic. At this time, we're switching gears to the panel discussion. I'd like to introduce our co-moderators, Omar Johnson of the Westbury Board of Health and Matthew Poole of the Edgartown Board of Health. They'll begin the panel discussion with some questions for our panelists, after which we'll be taking more questions from the audience once again. Matt and Omar, thank you again for both being here and willing to do this. And thank you to all of our panelists for joining us today. And with that, why don't you guys take it away?
Okay, I'll be starting. Wow, that was a very informative presentation. Thank you, Javier. Now for the panelists' questions, the opportunity to tap and learn even more from this extensive knowledge and perspective of these knowledgeable group that we've assembled today. And I will ask that you please introduce yourselves, provide a brief description of your work and area of expertise. What is one of your greatest concerns with regards to nitrogen, land use, and the health of our ponds? I'm going to ask that you be, very brief with your introductions, and we're going to start in a particular order. We're going to start with Dave, followed by Paul, followed by Chris, then Melinda, Michael, and then back to Javier again. So starting with Dave, take it away.
Yeah, my name is Dave Grundon. Recently retired from the town of Bluffs as their shellfish constable, biologist, warden, and so forth. We did a lot of environmental work in the ponds over my 20 years there with the town. And my biggest concern is with the health of our island ponds and with the increased nitrogen level in there and its degrading health.
Okay, thank you. Next will be Paul.
Hi, can everybody hear me fine? My name's Paul Bagnall. I am the shellfish constable, marine biologist, herring warden for the town of Edgartown, assistant harbor master. Had the job for 37 years. I've had the pleasure of opening Edgartown Great Pond during that time. Some of the other hats I wear is president of the board of directors of the Shellfish Group, as well as a state organization, the Mass Shellfish Officers Organization, and both nitrogen, ocean acidification, sea level rise has certainly been on all of our radar screen for a number of years. So I'll make it brief. I just wanted to answer the two questions that this does show a proof of concept to me. I think Edgartown Great Pond, I grew up in Edgartown from 7th grade, and my memory of 8th grade is that what are they digging this 20-foot deep hole in front of my house on Moore Street? And that was when the gravity-fed septic system was going by. At that time, our harbor was in dire need of cleaning up. It was grossly polluted. It created some room for renovation. We replaced the shanty and whatnot. I later went to school and then came back and was the town shellfish constable. And one of my proudest moments was when we realized that Edgartown Great Pond, but we had moved all this nitrogen out into Edgartown Great Pond watershed, and it was becoming a problem. We know we needed to go to tertiary treatment. We had to answer a lot of questions. But one of my proudest moments was in '92, the pond turned coffee cup brown, and 90% of everything that was there died in terms of shellfish, eelgrass, everything. It changed the pond for 5 to 6 years. And that was in '92. By '96, it was a done deal. We had done our homework. There was lawsuits filing around left and right, but town meeting went to town on it, and we took it on as a town, just under $14 million to upgrade our sewer plant from secondary treatment to tertiary treatment. We did increase a little bit of flow, but the wastewater coming out of our treatment plant now is of drinking water quality. So at that point in time, after that update, the sewer plant became a solution to the problems in Edgartown Great Pond rather than a problem. And we've been going to town on it. It's come a long way. It is one of my proudest efforts that I've done in my 37 career of the town, but let's not get too satisfied. It needs further monitoring and vigilance. So with that, I'll be quiet and let the rest of the people have their turn.
Okay, thank you, Paul. Next will be Chris.
Hi, I'm Chris Seidel with the Martha's Vineyard Commission. I'm the cartographer and GIS coordinator. And I guess, you know, sort of one of my concerns is just how to keep people engaged and how to make them feel empowered. You know, that perhaps there's something they could do on their own property that would help reduce nitrogen loading in the ponds. Thanks.
Thank you, Chris. And next will be Melinda.
Hello, glad to be here with all of you. I currently am the president of Tisbury Waterways, which is a pond caretaker organization. I started off in that organization many years ago and learned a great deal about the problems in our ponds, probably from many of you and those of you who are also listening in today. It brought me to the understanding that we needed new solutions to our nitrogen problem. I got involved in the town government and the county government, and with a particular sort of emphasis on wastewater and the decisions we were able to make about that. I think I worry about the biggest outcome of our not being able to find solutions will really be an economic impact on our island. I recently visited Chicago and a fish market in Chicago, and bay scallops from Nantucket were going at $80 a pound with a sign next to them that said, "It'll be a short season this year, folks." So that really brought the whole thing home to me. Thanks.
Yep. Thank you, Melinda. And next we have Michael. Michael, you may be muted.
Before I introduce myself, I can say that when I tell people, "Hi, I'm Michael Loberg," they tell me, "Oh, you must be Melinda's husband," right? So to put everything into a framework here, I am a member of the Vineyard Conservation Society. I'm the chair of a company called IGM Bio, which is a bioengineering company. I'm also the chair of the Tisbury Board of Health and a member of Vineyard Medical Care. I'll tell you what my biggest worry is. I'm actually optimistic that we can make improvements. I think this problem has occurred on our watch and perhaps our parents' watch, but I do think that we can leave our estuaries in better shape than we found them for our great-grandchildren. But I would say that I think the real issue is if the nitrogen, that septic nitrogen, comes from our food, we eat it, we excrete it as urea. If our population isn't controlled a bit, if it's just the subject of demand, we may create systems that we really can't control. And I think as we tackle the issue of nitrogen and water quality, we also have to tackle the issue of zoning. That's it.
Thank you, Michael. And Javier, you gave us an excellent overview of nitrogen. Is there anything that you'd like to add in regards to any concerns that you might have?
Well, actually, yes. It's something that has not been mentioned, or has only been mentioned like on the side, but probably one of the major concerns that I have in terms of nitrogen pollution and eutrophication of our estuaries and ponds, it has to do with the future. It has to do with climate change. We are kind of at a good position at understanding where the nitrogen is coming from, what the effects are, and we are starting to figure out how to solve the problem, how to little by little get better at solving this issue of coastal eutrophication. But climate change has the potential to change the rules of the game, right? The increases in temperature may change the physiology of some of the plants and algae that are responding to nitrogen inputs. Increased precipitation is going to increase runoff coming from land. The change in sea level rise is going to completely change the hydrodynamics of these systems with unexpected consequences. And so I think that that is one particular concern that I have, that in the future, we really need to be prepared to adapt our management strategies to a changing environment.
Okay, thank you. And moving on to question number 2, I pass this on to Matt Poole, the other moderator. Take it away, Matt.
Thanks, Omar. Javier, thanks for that fantastic overview of things that we've been hearing for a decade or 2 decades. It was just really interesting and fascinating to sort of get it all summarized in a nice, clean, fresh package. So thank you. And to our panelists, thanks for taking your afternoon and spending a couple hours with us. So in the same order, and I'll help you with recalling the order as we go, like Omar did, from each of your perspectives, can you, and some of you have already touched on this, describe the impacts that you've observed from excess nitrogen in our ponds over the past 20 to 40 years. And first up again is David.
Yeah, hi. Had to put the mic back on. What I've seen in the last 20 years or so or more, let me go back farther. When my family first moved to the island here in the late 1960s, there was a lot of eelgrass. There was a lot of life within the eelgrass meadows and so forth. And over that time, we have lost the eelgrass in most of our ponds. Some of that may have been because of the eelgrass blight, when a lot of it died in Siskinnket before I was a shellfish constable. But the 20 years, roughly 20 years I was a shellfish constable, we saw the ponds going downhill health-wise. The towns, all the towns, Oak Bluffs included, has put a lot of money into studying and seeing what condition the ponds are in with the Mass Estuary Project. And we have tried several different ways of monitoring it. We looked at isotope a decade ago. We didn't get really clean answers, but other things that can be done to help the other thing is Phragmites. This invasive species has come into our wetlands and into the marshes and so forth, and taking up a lot of space. There might be a chance to use the phytoplankton and the Phragmites, in a way that might be able to manage some of the nitrogen, but that's still to be seen. But the ponds may have sort of be stabilized a little bit, but I think there's a continued degradation of the water quality in most of the ponds.
Thank you.
Caught myself on mute. Thanks, David. Next up is Paul.
Hey, how you doing? I won't bother repeating what Dave had to say. I agree with all of it. It might be a little salient to just mark the eelgrass degradation on the island. I spent from 1980 to 84 harvesting bay scallops. We had Cape Hogue, we had Katama Bay, and we had Sedgwick and Tackett Pond as 3 areas to work on. We no longer have much eelgrass left in Katama Bay or Sedgwick-Kentucky Pond, and we rely on Cape Pogue probably for about 80% of our harvests now. Sedgwick-Kentucky is basically a family-only area, mainly because of the supply of scallops. So this is directly related to nitrogen in our waterways, and not only local water quality, but coastal water quality as well. In terms of bay scallops, on a regional basis in the mid 80s, everybody hit a kind of a decline. A lot of fingers were being pointed. Maybe it was MBTE or oil in the outboards or whatever. Since then, the islands, Martha's Vineyard and Nantucket, have been able to have a small rebound from that, along with a few towns on a cape. With the exception of a banner year for most people 3 years ago, it's been a 20-year run, for instance, for the town of Westport before they saw scallops again. And I have every confidence that has something to do with development in their watershed and nitrogen in their water. So yes, over the 20 or 40 years, I've seen huge impacts on the shellfish populations due to it's a multifaceted occurrence. It's not just nitrogen in the water. It's just a basic formula that I have as a population biologist, is that as your coastal population goes up on the island, the scallop population goes down. So with that, I'll be quiet.
Thanks, Paul. Chris Seidel?
Yeah, so I reached out to Sherry Casso, the commission's water resource planner, since she's really out there on the ponds way more than I am. And, you know, over the last 10 years, you know, that she's been with the commission, definitely there's been an increase in algal blooms and, you know, just observing that decrease, degradation of the benthic habitat and decrease of the benthic species. So, thanks.
I'm not worried about
Melinda, you're up.
They were there at the crack of dawn.
I want to echo what others have said in the loss of eelgrass, and I just want to add to that. Last year at the opening day of scallop season in the Lagoon Pond, I was out there, and through my peep box, all I saw was the surface of the moon. It was so devoid of any kind of marine life. So that is, I think, the biggest concern that nitrogen has produced in all of us.
Bye-bye.
And Michael?
Michael, I think you're on mute again. Sorry.
Thank you. I am educable, but slowly, apparently. I would, of course, agree with my wife. I do think that there are opportunities ahead of us, but I think time is not our friend. I think we need to act rapidly to restore what David described that his children got to have. And I think we can still make it for our grandchildren. But right now, portions of it do look like lunar landscapes.
Okay, thanks, Michael. And Javier?
Well, I unfortunately have not been in the area for 20 or 40 years yet, but yeah, I'm gonna try to respond to this question, kind of contributing a little bit with what I've seen, not only in this area, but in other parts of the world. I've done some work in the Mediterranean Sea, in the Baltic Sea, in the Atlantic coast of Europe, as well in some tropical locations like the Pacific coast of Panama and some islands in the Caribbean Sea. And all over the world, everywhere we go, we see kind of the same impacts of nitrogen pollution, right? Algal blooms, fish kills, shellfish kills, the disappearance of a very valuable habitat. But very importantly, and I wanted to add this, it's not just the loss of the habitat, but all the services that the ecosystem provides, and we humans benefit from it. And I'm talking about fisheries or shellfish, as it was commented, but also some other sources of income to our local towns and municipalities. I'm talking about tourism. I'm also talking about human health. I've seen myself because of nitrogen pollution in some areas in southeastern Spain, where I was doing my PhD, health issues like children going to swim in the ocean and getting some allergic reactions to some of the plankton that was present in the water, or jellyfish proliferations. And the tourists didn't want to swim or spend time in certain locations. So it's a very complex problem that not only affects the natural environment, but also our way of living.
Okay, thank you. And we'll go back to Omar for his opportunity.
Okay, the next question is addressed directly to Chris Seidel, and the other panelists will have the opportunity to add your thoughts and comments. Chris, in your role as cartographer for the Martha's Vineyard Commission, what are the primary land use changes you have observed across the island that would impact the pond's nitrogen load?
Thanks, Omar. So I'm just gonna share my screen and certainly I think the place to start regarding the land use change is really, first just sort of quickly introducing this difference between land use, which is how people are actually using the land, versus land cover, which is more the physical land type that's covering the ground. The data that comes from various sources, sometimes they do a pretty good job of trying to keep the two things separate, but often it's hard to tease out a land cover from a land use, but just good to sort of keep in mind. And to sort of emphasize that point, if we, so here in green, it's data from MassGIS from their land use land cover data set of 2016. So their land cover indicated that all this green is forest, which is like about 26,000 acres. So you can sort of get lulled into thinking, wow, that's probably all really pristine stuff. It's forest. You can't argue with forest. However, if we look at it from a land use perspective, that same data set, they sort of married together the assessor's use assignment for a parcel in with this land cover idea. So now all this multicolored stuff on the screen, it's all still a land cover of forest, but the orange is residential. That's about 11,000 acres. Agriculture comes out to be about just over 600 acres. So something to think about is, how is that resource being managed, say on all that residential land? Are people using fertilizers? Are they planting native? Is it non-native? Is it just invasive? That sort of thing. So sort of focusing still on the people, because obviously that's really what's creating all the change. So looking just at the census data from 1970 for the vineyard, we had just over 6,000 people. And now in 2020, for the vineyard, we have a little over 20,000 people. So that's an increase of a bit more than 14,000 people. If we sort of spaced ourselves out, in 1970, one person could basically have like 9 acres of their own space. Whereas now in 2020, if we spread all 20,000 of us out, we each get about 3 acres. So what are all those people going to do? Obviously, we need somewhere to live, so we're going to build houses. So there's this animated map that I made. This version was made back in 2014. So it's going to cycle through time, and each black dot represents a structure. And we're going to start here in 1900, and I'm going to take it up to about 2010 and just stick with existing development. So now we're cruising along. It's about 1930, 50, 60. So here we are in 1974. I'll just pause for a second. Now we're going to proceed on to about 2010. So definitely a lot of action going on there. People were pretty busy. Let's see. Looking at 2 land use data sets, again, from MassGIS, one from 1971 and another one from 2016. So when they do these classifications, you know, they break it out into quite a few different categories, roughly about 20. And obviously methodology changes over time, and also the definition that's explaining what each category is, obviously is a little different from one data set to the next, but trying to sort of make it all about apples to apples, and sort of aggregating those 20 different categories into just 2 categories and looking at undeveloped land versus developed. So undeveloped in 1971 was about 50,000 acres. In 2016, undeveloped land decreased to about 30,000 acres. Whereas developed land in 1971 was about 6,600 acres. And in 2016, it jumped up to about 27,000 acres. So if we look at that on the map, so here we are in 1971. Green is undeveloped and the red is developed. Now, if we want to switch it to show 2016, I'm going to proceed from down island to up island and just kind of swipe across the map. So now I'm sort of revealing 2016, and the red is developed and the green is undeveloped. So, you know, here's something pretty close to present day, 2016. And if we just give it one more shot to try and take that in. And I just wanted to point out some key things in terms of things to sort of think about. And it's one thing to sort of look at it island-wide and, you know, what is that land use? But obviously where things are positioned on the land certainly has a key impact on the water quality. As was pointed out earlier, groundwater travels very slowly. So certainly land use closer to the ponds, that groundwater will reach the pond sooner than the groundwater from further away. And I do find it interesting looking at this 1971 land use data set, and how even then, there's definitely a fair number of developed area, just hugging the ponds, looking at Lagoon Pond. I thought everything up here in Chilmark Pond area was kind of interesting, down here in Katama. And then another sort of thing to also think about is sort of the configuration of the land use, and not just where it is in relationship to the pond, but are we able to have sort of bigger patches of similar habitat, or is everything getting very fragmented? Are different habitats more connected? All of those things definitely come into play. And I think that's all I had to share for today. So I hope you found it interesting. Let's see. Here's the share. And I'll stop sharing my screen, hopefully. Sorry, I seem to have lost the button to stop sharing. I can make a map, but I can't do Zoom.
So David can probably treat you like a Zoom bomber and erase you here if he's quick on his controls.
And you can wiggle your mouse at the top of the screen, and a green bar should come up that says stop share.
Let's see, was that able to do something?
No. There's a red button that's blinking at the top.
David, if you make me host, I might be able to sort it out.
Let's see here.
Found it.
Yeah, there you go.
Where was it?
It was on the other monitor screen. Did that do it?
Nope.
No.
You did
There
it.
we go.
Yeah, we're back.
Thank you.
Nice.
All right.
Those were awesome, Chris.
Yeah, it was really, really good. Thank you.
Yeah.
You bet.
Definitely don't want me sharing my screen. So to Mrs. Loberg and Mr. Loberg in that order, what tools or techniques do we have available to us now to address excess nitrogen pollution on the land, as well as what makes its way to our ponds?
Well, thank you very much. Those maps were extraordinary. Thank you, Chris. As I began to sort through the tools that became available to us in our town, several rules of stewardship came to mind. The first, with respect to nitrogen, is don't put it in the ground. And to help us avoid doing that, we had sewer systems, and we had a few scattered advanced septic systems at our disposal. But those systems were not very effective, and they were kind of fussy to deal with and expensive. The second rule is, well, if it's in the ground, don't let it get to the pond. And some of the tools at our disposal there were use natural infiltration for stormwater management, preserve your wetlands and marshes, and the creation of permeable reactive barriers as a way to filter groundwater. Once it gets to the pond, the third thing is get it out of the pond. And for that, we had oyster farming and dredging for flushing. These are the tools that we had at our disposal. And it frustrated me as someone who was a wastewater planner for our town that we needed more tools and more technology. And fortunately, the world out there of engineering is beginning to respond to that and take note. And the town of Tisbury was able, through a mass energy center, let's see, clean energy center grant, we were able to do a public-private partnership to see if we couldn't assist in the development of one such technology that might help assist us in upgrading our septic systems, which the island, of course, is dominated by. And one of my best achievements in helping the town and the island deal with this was to interest my husband in the problem. And he brought his big brain to the problem. And now he's going to talk to you about how that worked out.
All right, well, thank you very much, honey. I'm going to go ahead and see if I can open up a screen here. That's pretty good. I'm going to need to get some people out of here. So oh well, this will work. Uh-oh. Well, let's assume we're not going to see all of it. I don't quite know. All right, we'll do that. See if I can. I don't really know what's going on here. That's encouraging. Let's do this. Let's imagine that this is a graph that has percent reduction. And we're going to be looking at the data that Mass DEP saw when they approved our technology to go to provisional use. But if I just show you one of these, let's say the number 770, that's the number of days that this septic system has been in the ground. These marks here are the concentration of nitrogen going in to the nitro system. And at the bottom, the green is what actually leaves the denitrification chamber and goes into the ground. More importantly is the extraction efficiency at the top for each of the samples. There was 13 samples that were that had 2 years or so that were given to the Mass DEP, and they approved us to go further. Let me see if we can get better. Okay, this is good. This is all the data now, including data from the Cape. And it's 19 of these, and the average discharge into the water over thousands of tests is 6.6 parts per million, or milligrams per total nitrogen. Before that, nothing had ever gotten below 11. In fact, nothing had ever gotten below about 19. But this, based on these data, the Mass DEP said we could go ahead. And I'm not going to show you the technology. Most of you may know it, but I want to show you where we are with the technology, just keeping in mind that we're removing 85% of the nitrogen that leaves the household. So here we are. These are just top line stuff. These are the top line conclusions and implications from looking at a combination of the 2015 Mass MEP report and the Nitro pilot program data that were given to Mass DEP. In 2015, we were told, the town of Tisbury, that it needed to remove 32% of the controllable nitrogen that's entering its two estuaries. That is Lake Tashmoo and the Lagoon Pond estuaries. It had to be, the 32% is 11,000 pounds annually. And that is of controllable nitrogen. So it's not acid rain or anything. The next thing that the MEP report said is that the Title V septic systems account for 80% of all controllable nitrogen waste in the Tisbury estuaries. We measured, the consortium that did this, including the commission, Martha's Vineyard Commission, we measured the concentration of nitrogen that was coming out of the households. And it was much, much greater than the 50 parts per million that they were hypothesizing, but we're still using something like that now. But basically, as was said in our remarks today, almost all of the nitrogen period is from wastewater, and 80% of all controllable nitrogen is. So here is the math. So if 80% of all controllable nitrogen is from septic sources, a 32% nitrogen reduction in groundwater discharge, our target, requires a septic nitrogen extraction efficiency of 40%. Here is the math. If you want to reduce it by 32% and 80% abundance of what you need to reduce is in the septic system, you need a 40% extraction of septic extraction fraction. If there's an issue on that, we can talk about it later. Let's look at others. Let's suppose you use the most common extraction factor, and that the older enhanced septic systems are maybe 23% extraction. And if you say the abundance stays the same, you could do target reduction down to 18%, this times this, but you could never get to 32%. And in April of 2014, yep, in 2014, the Board of Health sent a letter to Falmouth saying that they could not rely solely on an enhanced septic system that existed then, because their discharge has never been below 11%, and none are approved at that level. When they approve the nitro and their similar systems coming, to say that it basically is discharging, in their case, they said 10 parts per million. But basically it is much of what you need. And to show you, and this is also a take-home point, let's assume that nitro's extraction efficiency is 85% of the nitrogen gets removed. That times 80 tells you that we can remove up to 68% of the nitrogen, or basically we can remove about 40,000 pounds of nitrogen with these systems. I'll show you more about it, but I want you to see, this is how I teach myself, that we're in a position now to remove a lot of nitrogen, and we'll talk more about that. This is the Tisbury sanitary facilities. We have a Seward facility that serves 125 homes, none of which are in the watershed. And it was put in place not for nitrogen purposes, but for sanitation purposes. In 2015, there was 1,066 Title V septic systems outside the estuarial watersheds and 1,868 systems. If we retrofit, these systems can be retrofit, and we haven't talked about the systems, but they remove about 25 pounds on average each. 440 retrofits of existing Title V systems would remove the 11,000 pounds. And we'll say more about the importance of that. But today, the 5-6 years later, there's been about a 10% increase in development. So now we would have to retrofit 475. Basically, what's happened to us is while we thought nothing was happening over the years, something was happening. And that is the development was going on, but people didn't take responsibility for their household waste. They did for perhaps food waste, trash waste, but not for nitrogen waste. They put it in the ground and they walked away, thinking someone else would take care of it. Well, someone else will take care of this, but that's not sustainable for us to protect the ponds. This is Shubal Pond in Marston Mills. They are with government, federal funds, and other donations. They are trying to redress the issues at Shubal Pond. It's been closed for over 4 years to people. There's very little alive in it. And the green haze you see at the top is algae, and it's cyanobacteria specifically. The property values have gone down. The recreational values the homeowners say are non-existent. And they're going to be putting 20 some of the nitro systems in this area with federal funds and political support. The important thing is, if we want to look at the future, we could really get on a ferry and just walk into Falmouth, get off the ferry and walk into Falmouth. The issue really is this needs urgent attention. I wanted to give you just some takeaways on this. And they're here, 4 of them. Simple. Mass DEP Title V septic nitrogen proficiency targets have been met pending collection of additional provisional data. They may allow us some latitude without it, but we're assuming that we're going to have to get 3 years of data on about 50 systems. Another is just a saying, even when nothing's happening, something's happening. You can ask the Cape, you could ask the town of Tisbury. Time is not our friend here. The emerging new enhanced septic systems that we're talking about are what Mass DEP really likes because they're adaptive. If we can retrofit 440 systems, 11,000 pounds they want us to do. But let's assume that our math isn't quite right and it's 300 systems we have to retrofit, or it's 700 systems we have to retrofit. It's adaptive. It's not like you're building a big capital structure and you really need to fill it, to pay for it. This is a thing where you can remove the nitrogen and continue to monitor the TMDL, the Sentinel nodes. And they are very much in favor of us going ahead and removing nitrogen, which we can do right now. And to that, I say the denitrification of the pond should begin ASAP. We do have the tool. What we don't have is time to wait. So I give you one last slide, and I said I would keep this brief. I hope it's understandable. We're currently, this is the Tisbury Board of Health, and it says sometime before the year is out, we're going to be developing regulations requiring, this is the Board of Health, the installation of enhanced IA denitrifying septic systems capable of achieving a nitrogen groundwater discharge standard of less than 11 parts per million, or a nitrogen extraction efficiency of greater than 85%. And the following then lists the triggers that we have at the moment. And triggers are things that would cause this to be implemented. And these triggers can be satisfied by either a new retrofitted Title V system or a retrofitted Title V system. So here are the triggers. When new nitrogen enters the watershed as a result of any new construction that increases nitrogen watershed load, The homeowner has made a decision and they own the disposal of their nitrogen. They will have to probably retrofit their system. It's probably $20,000. It's probably not a big added cost on top of the construction, but it will be if we pass this, it would be a Board of Health regulation. When an existing septic system fails and is being replaced, when the system fails, it has to be replaced because it's a sanitation issue. The house isn't livable. But we would ask if the homeowner can afford it, and we don't have time to go into that, that the system be fitted also with an extra tank to do the denitrification. I believe that in my life, I've been disappointed on occasion because the aspirations I had for my great-grandchildren, I wasn't meeting them. I anticipated leaving this place in much better than I found it. And I don't mean the place being the vineyard. I just mean the places I go through in my life. Between the climate change and other issues, I have failed to perform. We can give the better ponds to our grandchildren than when we actually found them. I believe that, and it's time to start doing something. Thank you.
Thank you, Michael. I nearly crossed myself out of the meeting here. That was great, and that's an invitation to Dave and Paul to sort of parallel the conversation we've had about sort of the technology on land solutions, and ask them to comment on what tools are available on the biological and environmental resource side that we can draw on to help mitigate excess nitrogen in our ponds. So I'll let Dave go first if he's inclined.
All right. I think there's a number of things that we can do. There's no, one way to do it. There's a lot of things that could help. The advanced, either expanded soaring or advanced treatment of our septic system, it would be huge. There's areas where you could probably get a permeable reactive barrier put in to intercept the nitrogen before it goes into the ponds. Dredging in places could help. For farm pond, a larger culvert. The hydrodynamic studies that were done showed that would have enough increased tidal flow and flushing to bring that pond into compliance under the Federal Clean Waters Act. With the marshes around the ponds, the salt marshes, it's a couple of things you can look at. One is the restoration of it, trying to build up the leading edge of the marsh. We did this when I was working. We did a lot of this in one big project in Central Kentucky Pond, and the Susie Avazian from the EPA's Atlantic Ecology Division has submitted a paper for publication on that work, where we tried to stabilize the edge of the marsh where it had been eroding for years and years. One thing that I don't think has been tried on the island yet, it's had good results in other areas that I have traveled to see, and that is shallow deposition onto the marsh flats. As the water level rises and there is some dropping of the levels of the marsh, and you start seeing some of these marshes with no vegetation in the middle of them, they're becoming a salt pan. It's been shown that you put not real deep material, but put material on the flat, the marsh grasses can grow up through it. You're raising the level of the marsh to try to perhaps stay attuned or maybe get ahead of coastal coastal tidal heights. There's the other thing is you have to look at the shellfish. The shellfish have big potential. They all are filter feeders. The oyster can filter 50 gallons of water a day. And right now that is the money crop for private aquaculture. You know, and it could be put into the ponds in areas and try to reduce interaction with other activities on the ponds. You know, that's the reason why both Oak Bluffs and Egertown started oyster culturing in Sedgwick Pond, is try to bring that level down. In 2016, I gave a presentation at the Restore America's Estuary Conference and the Coastal Society conference about that work that we were doing in the pond, in Sedgwick Pond, with the influx of the new oysters 2 years two years out from starting, where we're looking at an average 2.5 to 3 inch oyster, a marketable oyster, that would take 50 gallons, that would do 50 gallons a day of filtration. Well, each town brings in 500,000 oyster seed and rows them out in protection. You have a high survival rate, and we're putting them back out into the water for future harvest. The numbers after the first 2 or 3 years, we had nitrogen levels before we started, and we monitored them for the next 3 or 4 years, and basically it basically stayed the same, although it did start to show a small reduction in the nitrogen in Sedgwick Pond. But the year following that, it was back. It came back up a little bit, and like it's been pointed out before, is that just a slug of groundwater from a larger development that has finally get into the pond? We don't know, but there's another possibility. I'm a Green Beach for the Shellfish Group, did a big study on Phragmites, and there's potential that we could use the Phragmites to harvest nitrogen and get it out of the system, depending on when it's cut and harvested, and it needs to be taken away. It can't just be cut down and left on the marsh. It'll just decay, and you're not going to really be removing the nitrogen. And they're looked at other, and her study also was looking at possible ways to use the Phragmites. And in a while since I looked at that, talked to her about it, but that's a big potential tool that we may have. So I think there's lots of small ways we can do it. I mean, but they're all going to cost money. Whether it's millions of dollars for sewering, or doubling Paul's budget so we can grow twice as many shellfish, or what. So it's all going to cost money to do. Some of the things are controversial. Like putting fill on the salt marshes. When I was working, I floated that idea to some people, and I backed off and trying to find money to do it because there was a lot of pushback on it. But there are 3 big projects like that are doing deposition on salt marshes in Rhode Island that are showing really great results. So I think that's another place where we could do. I mean, all the marsh plants, use nitrogen in their growth. There are a lot of things we can do. Some are small and chip away at it, and others might be have a more of an impact.
All right, thanks, David. we're gonna jump across the town line and see what Paul can offer.
Well, yes, it's a multifaceted attack on basically trying to holistically and as naturally as possible reclaim your water quality. As Mr. Loberg pointed out, a large player in this is septic systems, and it's a large amount of the nitrogen pollution. I've been casually watching this because my job is fortunately grow shellfish for the town and propagate, do enforcement on people harvesting said shellfish. Matt Poole, the septic systems are your job, right? But I was heartened. Oh God, it was around 20 years ago when they opened the Leachfield experimental station over at Otis Air Force Base, and we went to town on environmental systems. I have been a little bit disappointed in seeing what's come out of that because we're still in the experimental phase, and it's 25 years later. I was kind of hoping to get there in 10 years. And I think at this point, rather than create a whole nother industry, trying to put add-ons to Title V. Title V was, in my understanding of it, was written a long time ago as kind of a stopgap measure to get us through to something better. And it's about time that we produce something better. I echo the sentiments. I am constantly apologizing to people of the younger generation, Julie and Dan, that we didn't leave you with a better environment. And I think that, incorporating reactive barriers, pancake systems, they're all catchwords, but it basically comes down to using the effluent from in your gravel leaching area, mixing it with wood chips and sawdust. You need to aerate your effluent. You need to kind of slow the whole system down so that the nitrogen can resource it. And Michael, feel free to correct me because this is a shellfish biologist's view of it. But that the whole process could be accommodated by, and I know it's complex, it's not off the top of my head say, oh, gee, let's just rewrite Title V. The time has come for it because it is a significant factor on the pollution of our coastal ponds as well as the Cape. The higher the population density and the density of septic systems are, once you reach a certain density, central sewer system becomes economical. Until you're there, the denitrification on site, and I like the analogy of everybody is basically taking care of their own nitrogen that way. So with that, time is getting long and I'll be short for a change.
Thanks, Paul. And I'm actually going to cut in Omar and Matt, and just in favor of, we're way over our time limit here already. I've loved hearing from everybody, but I would like to just dive into a few questions from the audience before we wrap up here, if that's all right with everybody. And we'll just move right along. The first question is from Bob Landreth, and this is actually directed to Dr. Jouret, Javier, and it is, with the nitrogen isotopes, can you differentiate between nitrogen coming from stormwater runoff and coming from septic systems?
Yeah, definitely. The stormwater runoff will mostly reflect the signature of the atmospheric deposition, the atmospheric nitrogen, and most likely have a very, very low nitrogen isotopic signature. And the wastewater have very, very high signature. So it's relatively easy to tease apart those two sources.
Great. I've got another question here for Michael Loberg. And the question is, does the Title V septic system, does that remove phosphorus as well?
Oh, hang on here. The answer is no. We could, I've been told by the technical side, this was a public-private thing that did this, and I was on the public side of it. But the scientists on the private side said that that could be an add-on to the tank. But right now it is not.
Gotcha. No, thank you. I'm going to ask a question to, I think I'm going to address this to our resident boards of health, actually. And this is a question from B. In West Tisbury, our zoning bylaw prohibits building within 100 feet of the shore. If that were to be 200 feet, would that help prevent nitrogen seepage?
I'll take that one. That one's like that's a softball. No.
Yeah.
I mean, I think it was touched on probably a third of the way through or so, that there's old nitrogen and new nitrogen, and all that would do is sort of delay the arrival of the nitrogen at that shoreline interface. So I call it people per land area. And once you're in the watershed, there's a reasonable likelihood or high likelihood that your nitrogen is going to make its way to the pond shore eventually. So moving back delays the arrival, but doesn't really fix the problem.
Gotcha. I've got a question here for Paul. Do you have a record of productivity regarding shellfish? The key question is the Edgartown Great Pond now more productive with regard to shellfish after the town sewer was upgraded, in your opinion?
The pond is in much better health because of the upgrade of the sewer plant. When I took over reporting in 1990, I've broken out by town, by pond, also by recreation, by commercial, what was harvested on each body of water. Now, if you use that to gauge the productivity in Edgartown Great Pond, the weakness of that is in Edgartown, we generally go to harvesting oysters if we have a poor scallop year. If we have a banner scallop year going on, we'll leave the oysters for the next year because the scallops live for 2 years. Even with dermo, oysters will live to three to five. So you can go back and look at the general harvest records. You can also, in my annual report, see what was going on in terms of other remediation projects, shellfish growing projects, where we moved shellfish, whether we relayed shellfish from off island. So you get a general picture of what else was going on without the town. But I would if anybody was asking me about that data set, I would caution them about that caveat. When we put a 0 down for oyster in Edgartown Great Pond, and we have 15,000 bushels of scallops, that means we were busy taking the 15,000 bushels of scallops and we didn't get to the oysters. So I hope that answers your question. And I'll mute myself now.
It does. Javier, I noticed you had your hand up there just before I asked Paul that question. Did you have something to add?
Yeah, I just wanted to add a little bit to that a comment about prohibiting buildings 100 feet from the shoreline or 200 feet from the shoreline. Is not only delaying the time span for what that nitrogen needs to reach the ponds, but also, and very importantly, is to note that in a way, by locating septic systems so close to the water, we're bypassing the transit of water through the soil and the vadose zone and into the aquifer. It goes directly into the estuary. And so we are not taking into account the possible denitrification of that water that can occur through the soils or through the vadose zone. So more nitrogen enters the system if you are locating one of these systems closer to the estuary. The way the models that I have worked with tend to account for that is establishing a perimeter of 100 meters along the perimeter of the estuaries. And we consider that any house that is located within that belt, most of the nitrogen goes into the estuary directly without any denitrification, any interception in these other layers or in the aquifer, which is something of concern.
Can I follow up with a question, David? So Javier, can you comment on the percentage reduction as you sort of move back from the shoreline? Is it possible to summarize that?
Yes. So Yeah, the septics are bypassing the soils. So you are only going to have a potential denitrification within the Vado zone and another percent of denitrification within the aquifer. Now, within the Vado zone, there's potentially up to 65% reduction of that nitrogen. And within the aquifer, you can have a maximum, I would say between 15% and 35% reduction of the nitrogen. So by bypassing those two layers, you are actually receiving more nitrogen in the estuary. That's why, as a precautionary measure, preventing more buildings at less than 100 meters from the shore can actually a very helpful measure to mitigate nitrogen pollution.
But I would suggest so that folks don't get their hopes up listening in here that the very high percentage of our total nitrogen is from what I would call well back from the shoreline. It's 1,000 feet and greater back from the shoreline. So that's all coming no matter what, as we understand it today.
Totally correct.
Well, guys, it's coming in at 3 o'clock. We are 30 minutes over our predicted timeline, so I apologize for that. But I wanted to just say thank you all so very much for coming and joining us today, for sharing all this information. This is a massive topic. We could talk about this all day, I assume. But I think I'm just going to cut us off here, unfortunately, as we're just about out of time. But I wanted to give, again, enormous thank you to everybody. And just remind our audience that we do have another event next week on December 9th, where we're actually going to do a similar talk and panel session regarding harmful algal blooms, and then an information session after that for invasive species.